We chose to conduct our review on the manuscript entitled Enhancing Learning and Retention Through the Distribution of Practice Repetitions Across Multiple Sessions. The main question researchers wanted to answer with this paper is how practice repetitions should be distributed among study sessions in order to optimize retention. In conducting this experiment, the authors also wanted to address the knowledge gap in existing research on the spacing effect. They felt that the spacing effect has been extensively researched because it's an important topic and factor in learning, and wanted to expand on the current research by creating an experiment specifically exploring the effect of the distribution of practice repetitions. They tested different allocations of repetitions within study periods in order to determine how each type affects retention and which one would be best. The authors also wanted to create their study with a within-subjects design in order to provide a stronger test of the theory.
Based on this gap in research, the researchers looked at 4 types of learning strategies: 1 massed, where all repetitions are in one session, and 3 that are spread out in different ways, and assessed how participants' retention of information was affected. In the level condition, repetitions were equally divided among the total number of learning or acquisition sessions. In the ramp condition, the number of repetitions increased with each session, and in the taper condition, the number of repetitions decreased with each session. So the researchers of this paper hypothesized that retention would be lowest in the massed condition, while tapered practice would improve retention relative to the level or ramped practice. The study was a within-subject design on 38 participants. 20 were male and 18 were female. Participants were in the lab for 4 days and 3 nights, with no phone or personal devices allowed and no visitors allowed either. And before starting the actual experiment, participants did 2 practice sessions to get familiar with the stimuli. So this is an example trial. The 2-digit number in the line drawing combined is called a droodle. So participants were shown these types of droodles and then asked to type the 2-digit number corresponding with the drawing they see. In this case, the participant wrote 23, which was wrong, so then they were shown the correct number and a frowny face to denote that it was wrong. If it's correct, they're shown a smiley face. This is a schedule that all participants went through. Each schedule, seen as the rows, has trials where you're learning specifically 3 unique droodles. Participants see the 3 droodles 20 times each for each schedule. So for example, the 20 instances in the level condition are spaced evenly among 5 days, while in the tapered condition, the number of instances decreases with each day, but both add up to 20. So in total, participants are going to be learning 51 droodles. And every participant did everything you see on the screen, so that means all 17 schedules, which is the rows, for 11 sessions, which is the columns. 5 first day, 5 the second day, and 1 last day.
The core findings of this study are as follows. While the total number of acquisition sessions that an item appeared in directly affected final retention, the temporal distribution or the changing of distributions of practice across a consistent number of sessions did not affect retention. The highest rates of retention were found in participants whose practice was spread across multiple sessions, not in participants who practiced a singular mass study session. Repetitions were distributed across 5 study sessions, and retention was 1.9 times higher after 12 hours than retention after a mass study session. This level of retention increased to 5.1 times higher after 36 hours after 5 study sessions in comparison to the singular mass study session. Additionally, performance levels also remained significantly higher in the participants who partook in 5 study sessions rather than 1. Additionally, the participants that partook in 5 study sessions had a 93% absolute level of performance after 12 hours and a 78% absolute level of performance after 36 hours. Experiments have consistently shown that the number of study sessions had a greater effect on retention than the schedule or time in between used to participate in multiple study sessions. These results from the experiment are not just statistically significant, but educationally meaningful and relevant to a wide variety of fields. The broader implications for this experiment can be seen in many domains of the real world. A wide variety of people use the multiple study session technique, including but not limited to those in aviation, medical practice, performing arts, and even college students. Studying information over and over again can be the difference between someone getting their pilot's license or not, a medical license to practice on patients or not, someone's 5-star performance or the worst day of their career, or, like many of us, passing or failing a class. The utilization of multiple study sessions can better improve the absorption of information and overall retention of knowledge in various fields of learning.
An important strength of this experiment is that it's conducted using a within-subjects design. Each participant completed all of the different practice repetition distributions. Within-subject designs have greater statistical power and provide a stronger test of the hypothesis because each participant serves as their own control. Because of the within-subjects design, this experiment featured the most extensive set of different spacing conditions given to a single group of participants, providing a strong data set. Another strength of the experiment is that the experimenters focused on ways to make the study go beyond existing research. The study sessions were separated by hours instead of days or weeks in order to look into the importance of a period of sleep for spaced learning, which had been suggested as a factor in why spaced learning is effective. The researchers found that spaced learning within a single day resulted in similar retention to learning that was spaced throughout multiple days, indicating that sleep is not the only reason spaced learning is effective. This study also aimed to more specifically find the spaced schedule of learning that would optimize retention, with level, tapered, and ramp schedules set up for the participants to complete. This is distinct from previous studies that focused only on a fixed number of repetitions per session.
One thing the authors could have done better is increase the external validity of the study. As was said earlier, the study was done on participants who were in a lab with no outside contact and highly regulated schedules for 4 days. There is no way that these conditions are in any way indicative of how participants would perform outside of the laboratory setting, which is something that is especially important for researching learning and memory. When we learn and study things, we aren't sitting in a lab without any distractions and researchers constantly monitoring our every move, as you could see on the image on the slide. It might have been better to do the study in a way that better modeled everyday life and activities. Another weakness is that each participant experienced all 17 different study schedules using the same study materials. So in each study schedule, participants had to study 3 Drudel and number pairs, resulting in a total of 51 Drudel and number pairs that had to be learned, which doesn't seem that bad, but the fact that they are seeing all 3 Drudel and number pairs several times per study schedule is a little concerning. For example, at 3 o'clock in the afternoon on the first day, they would see the 3 Drudel number pairs for the level schedule 4 times each. Then they would see the 3 Drudel number pairs for the taper schedule 5 times each, and so on, resulting in seeing a total of 102 Drudel and number pairs in a single session. This was done 5 times a day, resulting in participants seeing Drudel number pairs a total of 510 times in a single day. This makes me wonder if there were some sort of fatigue effects on a participant's learning from one study schedule to the next, which might also account for the fact that, despite the hypotheses, they didn't actually find any significant differences between the study schedules. Being repeatedly exposed to the same type of stimuli could have affected their performance in the study in a way that wasn't related to the study schedules, but instead they could have been getting used to seeing the Drudel number pairs, or they could have been getting bored of seeing so many Drudel number pairs. So to maintain the within-subject design, they instead could have spread out the study over more days so it wouldn't be as taxing each day, or another option would be to have more of a variety in what types of materials the participants studied in the study schedules.
As mentioned, there are some issues and weaknesses with the validity of the study and possible confounds. When considering the participants of the study, it is important to note the method in which they were sampled and selected. Participants were sampled from a control condition from another study, which means that participants were not newly sampled for the present study and may not be representative of the desired population. Additionally, these participants, as sampled for another study, were approved and examined for physical and psychological agility, indicating signs of health and limiting individual differences. Because each participant is expected to engage with 17 schedules, this might have generated possible order effects such as fatigue effects, but also practice effects. Practice effects are confounds that result in familiarity and improvement across trials during an experiment. In this study, participants' retention and overall performance may have become enhanced throughout trials due to their continuous practice and familiarity with the procedure and not multi-session learning. As mentioned in the intro of the article, the within-subjects design of this experiment is unique and revolutionary in this field of study. However, the within-subjects design of the study invites order effects such as fatigue and practice effects, which are confounds that reduce the internal validity of the study and weaken the causal relationship between multi-session learning and retention.
One very real-world connection that many UCLA students can relate to is cramming in the quarter system. The quarter system waits for no one, so the most effective way to learn and retain information from each class is to utilize multiple study sessions rather than cramming every single detail from a 10-week lesson plan into a single study session. In my own personal experience, I've found that cramming doesn't work very well, and I need to learn as the quarter goes and study as the quarter goes. So if more students in the quarter system utilize the multi-session spacing techniques similar to this study, rather than cramming, then retention rates of information and grade distributions would be positively affected across the board.